Our planet is buzzing with life, cities sprawl, lights blaze, and information zips around the globe at the speed of light. How do we power our world without destroying it in the process? Energy isn't just about giant dams or sprawling power plants. It's about harnessing the forces of nature that surround us. From the sun's rays to the Earth's internal heat, each source has its own strengths and limitations. Join me as we unlock the secrets of a future powered by the very forces that shape our planet. Every day, our sun bathes the Earth in energy. Imagine tapping into this vast energy source directly, converting sunlight into electricity to power our modern world. Solar energy is rapidly becoming a mainstream energy source, with solar panels popping up on homes, businesses, and even entire communities. As the technology continues to advance and become more affordable, solar energy is poised to play an increasingly vital role in meeting our growing energy demands. The heart of solar energy lies in the ingenious design of solar panels. These panels convert light energy into electricity through the photovoltaic effect. Today's solar panels can convert up to 20% of sunlight into electricity, and research continues to push these limits even further. The benefits of solar energy extend far beyond its clean and renewable nature. Solar panels empower individuals and communities to take control of their energy production, reducing their reliance on large utility companies. This distributed energy model is particularly beneficial in remote areas or developing countries where access to reliable electricity is limited. Solar energy is incredibly versatile, adaptable for a wide range of applications. While the initial investment in solar panels can seem significant, the long-term savings are substantial. Homeowners and businesses can significantly reduce their monthly energy bills, sometimes even eliminating them altogether. Over time, these savings can more than offset the initial investment. The wind, with its restless energy, holds the key to a cleaner, more sustainable energy future. Wind energy, the conversion of wind power into electricity, is a rapidly growing reality. Imagine driving across a vast plain, the horizon punctuated by rows of majestic wind turbines. These turbines represent a future where we generate electricity from the very air we breathe. But how do these modern marvels actually work? A wind turbine operates on a simple principle: capture the wind's kinetic energy and use it to spin a generator. The process begins with the blades, aerodynamically designed to capture the wind's energy. This rotation spins a generator housed within the turbine's nacelle. The gearbox amplifies the rotation to a speed suitable for efficient electricity generation. The electricity generated by the turbine is then channeled into the electrical grid. Wind farms are often located on hilltops, plains, or even offshore, where the wind blows more freely and consistently. Wind energy stands as a beacon of hope in our quest for a sustainable energy future. Its benefits extend far beyond simply reducing our reliance on fossil fuels. Wind energy generates electricity without producing any emissions. This makes wind energy a crucial tool in combating climate change. Wind energy projects create jobs in manufacturing, installation, maintenance, and operation. Wind turbines have a relatively small footprint, allowing dual use of land. This dual-use capability makes wind energy a versatile and sustainable energy solution. Beneath our feet lies a source of immense energy, a constant reminder of the Earth's fiery origins. This geothermal energy is a clean and sustainable source of power. Imagine harnessing the Earth's internal heat, transforming it into electricity to power our homes, businesses, and industries. Geothermal energy is a reliable and renewable energy source available to us 24/7. From the geysers of Yellowstone to the volcanic landscapes of Iceland, geothermal energy is already being harnessed around the world. Harnessing the Earth's heat to generate electricity might seem like a feat of modern engineering, but the principles are straightforward. Deep beneath the Earth's surface, temperatures soar due to the decay of radioactive isotopes and residual heat from the planet's formation. Engineers drill wells deep into the Earth's crust to access geothermal reservoirs. In geothermal power plants, the hot geothermal fluid is used to spin turbines, converting thermal energy into mechanical energy, then into electricity. The geothermal fluid is then injected back into the reservoir, ensuring a sustainable cycle. Geothermal energy isn't just limited to electricity generation, it can also be used for space heating, industrial processes, and agriculture. Geothermal energy offers a compelling array of benefits. Its inherent reliability, minimal environmental impact, and diverse applications make it a powerful tool in our quest for a more sustainable and resilient energy future. Geothermal power plants operate continuously, providing a stable source of energy. Geothermal power plants emit significantly fewer greenhouse gases and pollutants. The heat from geothermal resources can be harnessed directly for various purposes, reducing energy consumption and emissions. This versatility makes geothermal energy a valuable resource for communities seeking to reduce their carbon footprint. Section 1. Nuclear energy, promise and peril. Few scientific discoveries have elicited such a mix of awe and apprehension as the power of the atom. The same force that binds the nucleus of an atom, when harnessed, can unleash unimaginable energy. Enough to power cities, but also enough to cause devastation. This duality of promise and peril has defined our relationship with nuclear energy since its inception. Nuclear energy stands apart from other energy sources. It doesn't rely on the sun's rays, the wind's force, or the Earth's heat. Instead, it delves into the very heart of matter, tapping into the immense energy stored within the nucleus of an atom. This energy, released through a process called nuclear fission, has the potential to provide clean, reliable electricity for generations to come. However, the legacy of nuclear energy is also intertwined with the specter of nuclear weapons and the devastating consequences of radiation. Accidents at Chernobyl and Fukushima serve as stark reminders of the potential dangers associated with nuclear power, fueling public anxieties and sparking debates about its safety and viability. Navigating the complexities of nuclear energy requires a nuanced understanding of its science, its benefits, and its risks. It demands a commitment to rigorous safety protocols, responsible waste management, and continuous technological advancements to mitigate potential hazards. In this exploration of nuclear energy, we will delve into the atom's heart, examining both its immense potential and the critical importance of harnessing its power responsibly. Section 2. Unleashing the atom, the science of nuclear fission. At the core of nuclear energy lies nuclear fission, transforming our understanding of energy production. Unlike burning fossil fuels, nuclear fission splits the atom's nucleus, releasing immense energy. This process hinges on the principle of mass energy equivalence. Imagine a uranium atom, its nucleus packed with protons and neutrons. A neutron striking the nucleus splits the uranium atom, releasing energy. This energy, explained by E=mc², makes fission powerful. A small amount of mass converts to a tremendous amount of power. Fission creates a chain reaction, releasing sustained energy. Neutrons from fission strike other nuclei, creating a chain reaction. This controlled reaction in power plants generates heat to produce steam and drive turbines. Uranium or plutonium fuel is incredibly energy dense. A small uranium pellet can produce as much energy as a ton of coal. This energy density results in smaller waste volumes, but radioactive waste requires careful handling and storage. Section 3. The power of the atom, benefits of nuclear energy. Nuclear energy offers significant advantages in the global energy landscape. It generates vast amounts of electricity without emitting greenhouse gases, making it a key player in our quest for a sustainable energy future. Nuclear power plants are reliable and provide a stable source of baseload power. Unlike fossil fuels, nuclear energy is carbon-free, crucial for fighting climate change. Its high energy density means significant power from a small amount of fuel, making it efficient and space-saving. Section 4. Guardians of the Atom addressing safety concerns. The promise of clean, reliable energy from nuclear fission comes with a profound responsibility, ensuring the safety of both people and the environment. The devastating consequences of nuclear accidents like Chernobyl and Fukushima serve as stark reminders of the potential hazards associated with nuclear power, underscoring the need for rigorous safety protocols, robust containment structures, and a steadfast commitment to responsible waste management. Modern nuclear power plants are designed with multiple layers of safety systems to prevent accidents and mitigate potential risks. Reactors are housed within heavily reinforced containment structures designed to withstand extreme events, such as earthquakes, tsunamis, or even aircraft impacts. Sophisticated control systems constantly monitor reactor conditions, automatically shutting down the reactor in the event of any anomalies. One of the most significant challenges associated with nuclear power is the safe handling and disposal of radioactive waste. Nuclear waste, generated during the fission process, remains radioactive for thousands of years and requires careful management to prevent contamination of the environment and exposure to humans. Various methods, including storage in dry casks and geological repositories deep underground, are employed to isolate and contain nuclear waste safely. The future of nuclear energy hinges on continuous advancements in reactor technology, safety protocols, and waste management solutions. Researchers are exploring new reactor designs, such as small modular reactors, SMRs, and molten salt reactors, MSRs, that offer enhanced safety features, reduced waste generation, and increased efficiency. These technological innovations, coupled with a steadfast commitment to safety and responsible operation, are essential for unlocking the full potential of nuclear energy while mitigating its inherent risks. Section 1. Our Energy Future, a Symphony of Solutions. We've journeyed from the sun's radiant surface to the Earth's fiery core, exploring a spectrum of energy solutions that hold the key to a brighter future. Solar, wind, geothermal, and nuclear energy, each with its own strengths and challenges, offer a glimpse into a world powered not by fossil fuels, but by the very forces that shape our planet. These are not competing solutions, but rather complementary pieces of a larger energy puzzle. Imagine a world where solar panels adorn rooftops, converting sunlight into electricity while wind turbines spin gracefully on the horizon, harnessing the wind's kinetic energy. Picture geothermal plants discreetly tucked away, drawing on the Earth's internal heat, while advanced nuclear reactors hum quietly, providing a steady stream of carbon-free power. This is not a utopian fantasy, but a very real possibility within our grasp. The path to a sustainable energy future lies in embracing diversity. Just as a symphony orchestra relies on the harmonious interplay of different instruments, so too must our energy portfolio encompass a diverse range of sources. This diversity enhances energy security, reduces reliance on any single source, and mitigates the risks associated with fluctuations in fuel prices or supply disruptions. The transition to a cleaner, more sustainable energy system is not without its challenges. Technological advancements, infrastructure investments, policy reforms, and a shift in public perception are all essential components of this monumental undertaking. Yet, the benefits of embracing renewable and alternative energy sources far outweigh the costs of inaction. Section 2. A Call to Action, Powering a Sustainable Tomorrow. The time for complacency is over. Climate change is no longer a distant threat but a present reality, demanding immediate and decisive action. The transition to a sustainable energy future is not merely a technological challenge but a moral imperative, a responsibility we owe to future generations. Each of us, as individuals, communities, and nations, has a role to play in this transformative endeavor. Individuals can make conscious choices to reduce their energy consumption, embrace energy efficiency measures, and support policies that promote renewable energy development. Businesses can invest in renewable energy technologies, adopt sustainable practices, and become advocates for a cleaner energy future. Governments hold the power to enact policies that incentivize renewable energy investments, phase out fossil fuel subsidies, and accelerate the transition to a low-carbon economy. International cooperation is also crucial for sharing knowledge, technologies, and resources to address the global challenge of climate change. The journey towards A sustainable energy future begins with a single step. Let us choose to embrace innovation, to challenge the status quo, and to demand a future powered not by the fuels of the past, but by the boundless energy of nature. The power to shape a brighter, more sustainable tomorrow lies within our collective grasp. Let's seize it together.